we will show that the sequence n plus I divided by in converges to negative I as n goes to infinity. So according to the definition, we need to control the modulus of the difference between the sequence itself and the proposed limit. We need this difference to be as small as we desire. So this is a small positive number. As long as the index is sufficiently large. So as long as the index is large enough, if the index is sufficiently large, then the difference between the sequence and the proposed limit should be small. So we have a tolerance that we will accept for the difference between our sequence and the limit. That's the tolerance. And we need n to be sufficiently large to make it so that we're within the tolerance. So we'll say that n has to cross a threshold. And that threshold we usually label as capital N. So the definition says, given an epsilon greater than 0, if there exists a number n, a natural number, so we have a tolerance given, and if there exists a threshold such that whenever such that the difference between the sequence and the limit will be less than the tolerance when the index is beyond the threshold. So the epsilon is given, and we have to figure out the capital N that makes this work. So in our case, our details are Cn is this fraction and C is negative I. So we let epsilon be greater than 0, and we consider Cn minus C, and this problem is n plus I over In minus negative I, so plus I. So we need the modulus of this fraction. Let's simplify things. This is plus I, and we want to add these together. So I want In on the bottom, so I have to multiply by In on the top. And this is n plus I times I is negative 1, so minus n over In. And this is I over In, which is just, the i's cancel, it's 1 over n, it's a real number, the modulus of 1 over n is 1 over n. So we need 1 over n, we want this to be less than epsilon, so we need n, solve this inequality for n, multiply both sides by n, and then divide both sides by epsilon. 1 over epsilon is less than n, or in other words, n has to be bigger than 1 over epsilon. So this is our threshold. We just want to express our threshold in terms of a natural number, so we'll just choose any natural number that has such that n is greater than this 1 over epsilon threshold. So choose any number, any natural number greater than that. Possibly very large positive number, because epsilon is a very small positive number. Its reciprocal then would be very large. So we want to choose n such that this happens. Then if our n is bigger than this n, we have, according to the calculation that we just did, n plus I over In minus negative I, this modulus, which is equal to 1 over n, is less than 1 over capital N, because if our index is bigger than the threshold, then taking reciprocals switches this direction. And this one is less than epsilon. If n is bigger than 1 over epsilon, then 1 over n is less than epsilon. That's the same calculation that we just did right here. If n is bigger than 1 over epsilon, and 1 over epsilon is less than n. We did it here with a capital N instead of a small n. So there it is. If our index is beyond the threshold, then the difference between Cn and C in modulus is less than the tolerance. And so that means the sequence converges according to this rigorous definition of the limit of a sequence.